And if we're doing that, then it will be installed in the local Maven directory if we're packaging it with Maven install. Then there's the packaging, which is basically APK for Android packages, of course. Here we can specify our dependencies. Since we don't need anything by now, we can just start with the platform itself. So we get the platform as a dependency here, which we didn't need when we were using Ant, but Ant was just hard-coded. This one is quite flexible, so we can change the platform version down here, and it's really easy. And then we got the plugin itself, which we can configure down there. And as you can see, I can change the assets directory, I can change resource directory, source directory is also possible, and I can change the platform version if I want. So this is not that hard, and this is a real POM file from a sample project which I was using at first. Okay, so this was the status quo for, let's say, a few years now, but with the Google I/O 2030, Google introduced a new build system, which is using the third build system on the market, which is Gradle, and of course they did it with the Gradle plugin. Gradle is based on a Groovy DSL, so you have no more verbosity, I think. It also got a built-in dependency management system, so this is also quite flexible, and it's using standard Java patterns, so you don't have this source directory where you can put your source and a test directory where you could put your test, but it's using the standard Java way. So we're putting our source in source name Java, we're putting our tests in source test Java, and we're putting our instrument test in source instrument test, then that Java. But if we don't want to do this, it's flexible enough to change this. If we just want to stick to our old way, this is possible also. Yeah, and there are some more plugins coming with it. So we got a unit test plugin which we can use and which we can just apply, and if we apply it, we can just do our unit tests. The instrumentation tests for the first time are also within this, the same project, so we don't have to implement another test project. This is really a great thing that comes with the new build system. So let's see one of the first basic examples that come with it. So here up there we just configure our build script. Then we have the dependencies, which is basically we have to load the Android plugin itself from Maven Central, which we configure here. Then we can just apply the Android plugin. This one uses all the switches which are located down here. So here we just configured all the SDK versions, but we could do more down here. And then we got some dependencies which we don't need. You can see we have two dependencies here, one for the build script and one for the application itself. And then there's the Android part. And that's it. So no more clutter, and everything's arranged in a pretty nice way. So this is, in my opinion, a great new development. And it even gets better, because with it, Google introduced the Android Studio. So before we had Eclipse and the ADT plugin, but this one is a really cool way to implement your applications. So the basic facts are it's based on IntelliJ, which is way better than Eclipse, of course. And then it's also ready to use, so you don't have to download Eclipse first, then download the ADT plugin, then download some extra plugins. Everything's built in. You can still add some more plugins if you like, but the most important ones are already installed. Yeah. There's also some shortcuts, so the AVD and SDK manager are at hand. If you like, I can show you where. We can just start the AVD and SDK manager with these buttons up here. And it also brings its own SDK version with it, so you don't have to install it for yourself. And what's even better is there's out-of-the-box support for the new build system. So you can start using the new build system today, and you don't have to rely on stuff like Vim for programming. You can use a real IDE for it. And what's even better is that there is a possibility to migrate old projects, old applications. So if you just got an old app which is using an ARM-based plugin, an ARM-based application, then you can port it and bring it to the new, easily bring it to the new build system, if it's not too customized. But that's a really great thing, and I think that's okay. Okay, so enough about the build system itself. Next thing I'm going to talk about is RoboJuice. So, what is RoboJuice? We got this logo down here, which we just downloaded from their page. It doesn't show anything. So RoboJuice basically is a dependency injection container. So if you've never got into touch with dependency injection, the next few sections will be even more confusing. It's an implementation of the JSR 330, so the Java request for dependency injection. And it's a fork of the famous Juice framework for the JDK, so it doesn't only run on, so everything you're developing doesn't only run on your Android. You can easily port your code to the JDK also. And it's easy to configure and to use. So it's quite a simple implementation of this JSR. So who hasn't used dependency injection before? Okay, a few. For those of you, I'm going to give a short introduction. The basic principle of dependency injection, or inversion of control, that's the bigger phrase for it, is instead of taking, so here we're taking our location manager and the onCreate method. So basically the class loads, gets a system service out of the system and puts it in its own location manager variable. Instead of this, we want to be given the location manager. So we just put an Eject here, and the RoboJuice build system is taking care of it. So we don't have to take our objects anymore. We are given them. And this is the most important principle of DI. So in short, it's never let a class create its objects for itself, except for the really simple objects. Instead, they should be passed to the objects. And why do we do this? We got a lot of experience, 10 years of experience or something like that, with with taking the objects for themselves. Well, it's because we can change exchange the objects easily. So we can put in other objects where the placeholders for them are. So we can pass in test doubles for unit tests, for example. Or we can exchange real objects. So if we got an interface, we can easily exchange this implementation with another implementation this way. So all that dependency injection is about is loose coupling. So we're trying to bring loose coupling to life. Yeah, and that's the basic parts of it. How do you do it now in using RoboJuice? Well, basically,
Excuse me. May I ask a question?
Yeah, of course.
So, in a couple of slides before, you had, was it a macro you had? Yeah, at Inject, you say.
Yeah, this is a Java annotation,
Right.
and what RoboJuice basically does is it searches for these annotations and then uses some reflection magic to put the objects in that it thinks that belong there. And so basically all it's about is just finding the places where these injected annotations are and then putting in the right objects, which means calling get system service if we are in production.
And on which stage happen then?
Normally directly after the constructor is invoked. But yeah, directly after the constructor. Okay, so how can you inject it? You can also do it with the constructor, so you can inject the constructor itself. So you don't have to call the instructor anymore. You can constructor anymore. You can just put the inject annotation here, put in the location manager in this case, or anything else you like, and then assign it to the field you want to do. You can inject into fields itself, so you can just put the inject annotation at the field, or you can use a setter. So a property is fine for it. You can just put the inject here. Yeah, so what can be injected? Yeah, well, there's a lot of objects that can be injected. First of all, there's zero-arc constructor objects. So every time we got an object that has a constructor that we can directly call, we can inject it. We can also inject all the objects that are managed by RoboJuice itself. So if we got an inject at an object, we can inject this one also. We can inject views. So this is really cool because before we had to find the views, so activity we find view by ID, blah blah blah. Now we can just put this annotation on there, and our onCreate method gets a lot less cluttered. Resources are also possible, so instead of using inject view, we can use inject resource here and just provide the ID as we did up there. And in this case it's a drawable, but we can inject every resource that we have. And there's also a lot of standard Android objects. Most of all, there's all kinds of managers, like the location manager, the asset manager, blah blah blah, the alarm manager, notification manager. So everything that's manager-like can be injected, and as always, yeah. And as always, a vibrator can be injected. Okay. Yeah, that was a bad joke, I know. So how can you enable your application to do some dependency injection? You just have to implement the robo classes. So instead of using the standard classes, you just extend the robo ones. So there's a robo activity instead of an activity. There's a robo list activity, there's a robo service, a robo fragment, blah blah blah. For everything that we got a robo implementation of it. And with it, dependency injection is done for free. So what is if you don't want all the objects created at a startup? So I need some objects which are dynamically created. This was a real problem for me at first. So I need an object at runtime. This can be done using providers. So a provider is basically just an interface that has a get method. But if you implement it, you can also inject objects into it, which I'm doing up here. So some other object is injected. And then within the get method, we do what we would usually do. So we call a new some object, pass in the injected object some other object, and then we can get dependencies out of it. And every time I call some object provider.get, this one is invoked, and it you can get a new instance of it. I'll have to say this is not done every time, but there's the scoping thing. I'll talk about scopes a little bit later. So if you're using a singleton scope, it's only provided one time for the whole application. But I'll get to it. Okay, if we want to get even a little bit weirder, we can also inject injectors. So if we want to get arbitrary objects out of our context, our RoboJuice context, we can just put the inject at an injector object, and then we can use injector get instance, and with injector get instance we get the class, an object of the class we pass in. And it's doing all the magic behind the scenes, so it's injecting all the necessary stuff in there. So everything is done for you. But I wouldn't like you to just use the injector, because it's a little bit redundant, I would say. So if you can do it without injecting injectors, don't do it. If you have to, it's pretty nice, but maybe it was wrong to telling you about it. Yeah, and that's basically it. Everything else that can be done using configurations. To do some configuration, you will just have to extend the abstract module, and then you will have to override the configure method. And what can you do within the configuration? You can bind an interface to an implementation. This is only necessary if there are if there is more than one implementation for an interface. And if you bound it to a specific implementation, you can then easily exchange it by just putting in the other implementation here, and you'll get the other implementation injected. You can also bind providers to the classes they provide. So this is again for when you have more than one provider, everything else comes out of the box. And there's also the thing with the scope. So basically with RoboJuice version 1, you did all the scope declaration down here. Now you can do it at the class itself. You can put an add singleton before the class, and it becomes a singleton. So it is only injected once. Or you can inject a context singleton, which means that it is just provided once per context, so once per activity, service, or something like that. Yeah, and once you get that, you can register the module by putting a resource in. So the resource is RoboJuice modules XML, and you just have to put the fully classified qualified class name in there, and all the modules you specify there are registered. And that's it. So to sum it up, what do you have to do to integrate RoboJuice? First of all, you have to put it in the dependencies. So the dependency section that we saw before, we can just put in a compiled dependency for RoboJuice 2. Anything. Then you'll just have to extend the robo classes instead of the normal classes. Then you can inject your dependencies with the add inject viewer, or add inject resource annotations. Then you can configure a module. You don't have to configure a module, but if you need it, you can do it. You can register the module then. This is important if you have one. And then you can start writing unit tests. So, how do we write unit tests? This is what Andreas is going to talk about.
Thank you. At first I would like maybe to put out some questions. How many of you already had some experience with Android development? So just a little bit, it's enough, but that's nice. So we will go into some problems you may get there. As I will talk about Android testing. How many of you had the urge to do some tests developing applications. Okay, still quite a lot. So the experience we had so far, we ask other people, how do you do testing? And most of the people say, I don't test very much because it's so difficult. Maybe it's the experience you had as well. The problem with Android testing is that if you're developing Java not in your free time, but for business purposes, you don't use JUnit 3 usually because JUnit 4 is out, as Thomas said, since some years. Android testing, if you're talking about the Android testing which was possible by the Android system, had to be done or has to be done with JUnit 3. This was a separate test break which now was removed with the new build system, so this is luckily gone. But still, if you want to do instrumented tests or Android-based tests, you always have to use the emulator or hook up a real device to run the tests, because the tests only run in the real Android surrounding. And the problem there is that there are some frameworks that already started to bring in some mocking possibilities, but it's not really in there. So there's this initial support, and that's really obviously ouch. It's so easy if you're doing testing on Java, and if I want to test my Android applications, why is it so difficult? And a lot of people saw this, and they were just looking into what is the problem there, and why can't I run tests just locally, like I do when I'm just doing a Java development. I have my separate test sources directory, and I put tests in there, and I just press run tests, and they just run in very short time because they compile and run in the local machine. So no emulator, no real device needed. And unfortunately, if you start with bare Android development, it's not possible. Just tell you why. If you try to run tests which use some kind of Android functionality, you will very quickly end with this kind of runtime exceptions that just say stop. The problem or the thing behind is that the SDK jars, which you usually use when developing on your computer, they are only stubs. So they don't have any functionality of Android, they just look like Android jars, but they are in principle empty. And of course, then you have the question, can I work around this? And luckily, people did. They developed Roboplan, which is around for, I think, for some years now, luckily. And this is the logo of Roboplan. And I would like to take the opportunity to show you some details how to use Roboplan, how to integrate it, maybe also in the new build system. What is Roboplan? It's in principle some kind of wrapper which works on top of the Android SDK to make Android SDK somehow usable on your Windows machine, on your Mac, or whatever you develop. And to use it, it's just another dependency for your project. So we can add it as the dependency of Robotools. And in the background, it of course uses some magic to enable to run local tests on top of the SDK jars. And unfortunately, so there was a little change going from version 1 to version 2. And at the moment, it's quite a huge framework. It's not to all edges of Android. It's not yet complete, but you can run most of the things without doing anything. And in the next slide, I would like to show you what do I get if I use Roboplan. The very good thing is that tests are running on your local machine, which means they are very fast. You don't need to start up the emulator, you don't need to hook up a device. The good thing there is you can also test your project, for example, on a continuous integration system like Jenkins, without the need for where it's very difficult to set up an emulator. You can use, of course, current JUnit 4 for doing your testing. So if you're used to work with JUnit 4, you don't have to go back to JUnit 3 for testing. And the next good thing is that you can just use the mocking framework like Mockito, which you are used in ordinary Java development as well. So there's no need to learn a new thing. You can also take your knowledge from there. And you can also Of course, sometimes you would require to do instrumentation tests in special cases where you really want to have a look at the behavior of the UI. But there are a lot of cases where you just want to test the functionality of classes, how they work, how they calculate. And this is the application of just a local unit test on your machine. How do I enable Roboelectric? That's also quite easy, not that easy compared to RoboJuice, but luckily some people already tried to integrate Roboelectric into the new build system. And there exists, it's below 0, but it's at least a version of a test plugin. So you add the dependency to the test plugin, and then you add, so you have the dependency here, then you add the line to apply this plugin to your project, and then you are, at least for the graded part, you are done. And what is the way to implement a test? Here's just an example. And here you have a test class, you have the button, you have the test class, you have the annotation to set up the test, you have the annotation for a test method, you have some assertion inside. That's what you know from JUnit 4 testing. The only difference is what you see up here. You just run this test with a special Roboelectric test runner, which does all the magic for you. So if you see this, it's also very easy to just copy existing Java code and the test to an Android device, because you just add this test runner.
Show the dependency again?
Oops, no, I have to go this direction. There it is. So this is something which you find very quickly when you Google it. So that's the class we already have seen. And just a little bit about the basic concept. The basic concept of Roboelectric is the shadow. And here is just a short example how these shadows are used. What you see here in the first line is just normal Android code, which you have to use when you don't inject a view. So you find the view by ID, you have the ID of the view here, you cast it to the target type, which you have to know, and then you have the text view. And the problem there is when you want to do some tests, it's difficult to get the text from the text view, because the text view has no get method. And Roboelectric has the possibility to create a shadow object of this text view, which is just called shadow text view. So you just put shadow in front. And then you have, this is starting to be some kind of mocking or some better access to object properties. You can ask the shadow text view, what is the text of this text view? And you can check this if this is right, for example. So usually this is also always running in the back. This question.
I'm pretty new to testing.
Yeah.
How is this is method working? Because what does it do?
So this is the assertion is a special feature which has developed over the years that it's easily readable. So usually, if you remember testing in former times, you had assert equals, and you had two values, and it was asserted that these values are equal, but the problem there is you don't know always what is the reference and what do I want to have, and where's the value I check. And therefore, people improve the system that you have this type of assertion. And in principle, this is a kind of matcher stuff. So it's, unfortunately, I cannot explain it in total here, but it's a little bit magic. But so this is a dependency, or this comes out of JUnit, and I think is a method, a static method from Hamcrest.
Yeah, it's a Hamcrest matcher.
And the Hamcrest matchers, it's in principle a standard package implementing these kind of matchers, which are provided by JUnit to make magic stuff here. You can also, if you have a collection here, you can also assert that collection contains blah 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 some values. So
we could talk about
very precise tests.
We could talk about this later on.
Yeah.
Okay. Thanks.
Okay. Well, that's the test, and this the implementation, Roboelectric, it's not interesting at the moment because this had to be done in versions before 2. You had to do this on your own sometimes. In version starting with 2, Roboelectric comes with a lot of shadows for different purposes, and just what you can take with you. The shadow always has some kind of real object which is wrapped. So the real object is contained in the shadow, and then you can access more stuff as you could do with the original object. Again, for some basic concepts of Roboelectric, to make Android testing possible, Roboelectric also builds up a full application context, so you can also, for example,